Okay, so this is the third video on this section, and I'm hoping it will be the last one. One thing I did want to say about the previous question is if you wanted to do the counting, you could stretch your, graph your first graph, the y equals ax squared, and a is 4, so y equals 4x squared. And so basically you would be taking these and multiplying, right? When you put in the -1, you would be multiplying by 4. So let me take these off for a minute. So at 1 you would be at 4, and at -1 you would be at 4. And then from there you could count and not get confused maybe with the multiplication, right? Because then I can count to the right 4, 1, 2, 3, 4, and up 2. And then from this one, 1, 2, 3, 4, up 2. So just a thought there if that helps any. Finding a point on either side of your vertex and just plugging it in works fine. And it gives you practice with that too, you know, just the substituting in of a number. Okay, let's look at this next one. So on this one, we have a vertex at +2, -6, because remember that's my h and my k. And then it opens downward. And the axis of symmetry is at x equals 2, because that's the x coordinate of my vertex. And then it shifts right 2 and down 6. Also, it is a reflection, right? So it does reflect because it opens downward. Okay, so if we graphed y equals -x squared, because that matches with our -1 here, on this one we could just count, right? So let's take a look at that. If we graph the reflection of our parent graph, basically I'm just trying to find ways to help you figure these out as simply as you can, because it feels like, I'm sure when you're looking at these, oh, there's a lot going on, and truly there is quite a bit. Once you can find everything though, I believe that it's not too bad, right? Now we are shifting right 2 and down 6. 1, 2, 1, 2, 3, 4, 5, 6. Notice we're at our vertex of 2, -6 just by counting. And so you can find the vertex that way, or you can verify that that's where your vertex is. So if I count from my point on the right, I'm going to count right 2 and down 6. I'm going to count right 2, down 6 from my point that's on the left, and then draw my parabola. I seem to always have some extra squiggly stuff going on. Remember, this is curved. Oh, I just put that on there. Okay, so this is our parabola that opens downward. Don't forget your axis of symmetry. You know, I can forget these things too sometimes, so we don't want to do that. And now we have this one graphed. Okay, it does not get more narrow or wide. It's the same. It's the same width as our y equals x squared, or y equals -x squared. Okay, so let's look at all the details on this one. We have a vertex at -4. Remember, we're just going to do the opposite sign to that number in the parentheses. -4, 3. This one opens down. It's going to have a shift of -4 to the left, and 3 up. It's going to be wider than our parent graph of y equals x squared, or y equals negative x squared. You can look at that that way too. Okay, so let's just start here by graphing negative 4, 3. 1, 2, 3. If I were to choose some points here on either side of this, this is sometimes where it gets a little bit tricky with this negative 1/5. So I want to show you, how do I find some points? Well, we want to find numbers that when I add 4, they're divisible by 5, right? And so you can kind of think your way through this. Usually the positive one's the easiest one to look at. If I want it to be divisible by 5 and I just added 1 to the 4, that would count, right? That would work, right? And so if we put in 1, right, and add it to 4, then I'll show you how this works. So 1 plus 4 squared plus 3. So 1 plus 4 is 5, and 5 squared is 25. Then we take 25 times negative 1/5, which is negative 5 plus 3. You know, you can key this totally into your calculator and just all in one time, one calculation using parentheses, if you have the kind of calculator that does that, which a lot of them do. And so notice that this 1 was 1, 2, 3, 4, 5, negative 2. It was 1, 2, 3, 4, 5 to the right. So that must mean that if I go 1, 2, 3, 4, 5 to the left, I'm at negative 9, then I'm going to have my symmetric point. Oops, I need to write that as a 1/5. So negative 9 plus 4. Well, negative 9 plus 4 is negative 5. Negative 5 squared is 25. So you can see we end up with the very same ordered y coordinate, not ordered pair. My axis of symmetry, did I ever name that? I guess I didn't. Is at x equals negative 4. All right, so let's graph this other point. My symmetric point is over here at negative 9, negative 2. This is a very wide, and it's very wide because of that negative 1/5, right? Because the larger the denominator, the wider it's going to get. And then graph your axis of symmetry. X equals negative 4. And so that's it. We found everything. All right. And here's the next one. Okay. So on this one, I wanted to show you one like this because I know that it may seem a little bit weird because it has a fraction for our vertex, and there are some on this section that way. Okay, so let's name the vertex. It is at 3/2, 1, and typically my MATLAB wants you to put in fractions as fractions, not decimals, so you want to do that. This one opens up, and we have an axis of symmetry. I don't want to leave that out this time. At x equals 3/2. And then we have to figure out how to graph this thing. Now this does shift, and it shifts right 1.5, right 3/2, and up 1 from our standard graph. Now because this one, right, has an a of 1, right, my a is 1, then there's not going to be any multiplying, which makes that a little bit easier. So let's see what we can do here. If we do this way, my standard parent graph, common graph, it's called a few different things depending on the book, has these points, right? So if I'm going to count right 1.5, just think of it. I know we're going to write it as 3/2, but that's 1.5. So if I count to the right well, first of all, I can graph the vertex because I already know it's at 1.5, 1. Right, so here's my vertex. Now let's look at that though. I counted to the right 1.5 and up 1 from my vertex. Now from these other points, if I count to the right 1.5, I'm right here, up 1, there's going to be that side of my parabola. And from this point, I count over 1.5 and up 1. And I honestly feel like this is probably the easiest way on this one, and that's because A is 1, so that makes it a little bit easier. Okay. I'm just going to take those back off there. Okay, I just can't seem to get this drawn correctly. I'm going to go back to this one. Okay. Well, that'll have to do. And then my axis of symmetry is going to go through my vertex. X equals 3/2. And there we have it. Now, I know that last drawing, a little sloppy on that. Sorry about that, but that is it, guys. So I hope you'll be able to graph these. Just being able to identify your vertex is very helpful. And then you just need to point on either side of that vertex to get it graphed. All right, that's it. Bye.